So now we're going to go through just a few extra examples to make sure that you get the idea of this. So I've drawn out a hydrocarbon for us, and we need to come up with the name of it. So first thing you do is you find your longest continuous carbon chain. So if we go straight across here, there'll be 1, 2, 3, 4, 5, 6 carbons. If we go over and down, that would also be 6. Over and up would be 6. So 6 is going to be our longest. So we might as well just go straight across and count that as our continuous carbon chain. So 6 is hex. And again, we can get that right off of the reference table. They have single bonds, so hexane. That leaves behind 3 branches. So branches have to get the YL ending. So you might as well put those in right now. Then you look, see how many carbons are in our branch. There's 1 carbon, so that would be a methyl branch. 1 carbon, that would be another methyl branch. 1 carbon, we have a 3rd methyl branch. We do not say methyl, methyl, methyl. That sounds a little silly. So we say trimethyl hexane. Then lastly, we are going to need 3 numbers out in front to give the location of my 3 methyl branches. If I start numbering over here on the left-hand side, moving towards the right, my branches would be off of 3, 5, and 5. If I start from the right-hand side, moving toward the left, then my branches would be off of carbon 2, another one off of carbon 2, and off of carbon 4. So that is going to be the winner because that totals the lower numbers. Now, an important note here, you can't mix and match your numbering, so you go all one direction or all the other direction. So the name of that compound would be 2,2,4-trimethylhexane. All right, so we have another example that I have drawn out here. So if we're going to name this, first thing we have to do is find our longest continuous carbon chain. So if I go straight across, that's 5 carbons. If I go straight down, that's 5 carbons. If I go over and down, it's 5. Reverse and down, it's 5. There, it's 5. So any way I go, it's going to be 5 carbons. So pick 5 carbons. That's going to be your continuous chain. I'm just going to pick straight across. So straight across here, 5 carbons. 5 carbons would be pentane. So the end of my name is going to be pentane. All right, that leaves behind a branch and a branch. Branches get the YL ending. I got 2 carbons in the branch. 2 carbons is F. Again, 2 carbons, F. We don't say ethyl, ethyl. So this would be diethyl pentane. And then the last thing we need are our 2 numbers out in front. So if I numbered this way, they would both be coming off of carbon 3. And if I numbered in the reverse direction, they would also both be coming off of carbon 3. So it does not make a difference. So we are 3,3-diethyl pentane for the name of this compound. All right, so we got one more example. This one's a little confusing here. So we got to find our longest continuous carbon chain. I was missing a bond there. So if I go straight across here, that would be 1, 2, 3, 4, 5, 6 carbons that I could connect. If I went across and down, that would be 1, 2, 3, 4, 5, 6, 7 carbons that I could connect. If I go from here, though, I could connect 1, 2, 3, 4, 5, 6, 7, 8 carbons. Other thing I could do is go this way and then up, but that would also be 8. So let's say we go down here, across, and down for 8. That would give me octane. Because 8 carbons and they all had single bonds. That would leave me that branch, and this branch over here. So all of my branches have to get a YL ending. Okay, 1 carbon in the branch, so that is a methyl branch. 2 carbons in the branch, so that is an ethyl branch. 1 carbon in the branch, that is another methyl branch. When you go to do the name, it doesn't matter what order you go in. So you could say blank, blank for the numbers, dimethyl, because there's 2 methyls, blank, ethyl, octane. Or you could have said blank ethyl, blank, blank dimethyl. So basically, dimethyl, ethyl, doesn't matter which one you list first. In order to do our numbering, we check either direction. So if I start up there at the top, I would use the numbers 3 and 6, and then 6 for the ethyl. If let's see, we'll do them in blue. If I number here, I go 1, 2, 3. Oh, that would still be 3, 4, 5, 6, 7, 8. Then I would be 3 for one of the methyls. I would also be 6 for the other methyl, but I would be 3 for the ethyl. So the blue numbers win. So I got to get rid of those yellows. So I would be 3,6-dimethyl, 3-ethyl octane for the name.